Welcome to this explainer. Okay, let's jump right in. Today, we're looking at a world-class scientific endeavor that is literally hiding in plain sight. We are going to examine how Japan's civilian space agency, JAXA, possesses the exact engineering hardware, the physics, and the capabilities of a latent nuclear weapons program. Let's dive into the mechanics of how this actually works.
Look at this quote right here. A weapons program disguised as a space agency. That pretty much hits the nail on the head for what we're talking about today. It turns out, the technology required to explore the cosmos perfectly mirrors the engineering needed to build a nuclear arsenal. I mean, landing probes on asteroids or building space station modules, that requires the exact same physics as delivering a payload anywhere on the globe.
To really get this engineering parallel, we need to talk physics for a second, specifically GTO, or geostationary transfer orbit. This is a highly elliptical Earth orbit used to place satellites way high up above the equator. But from a strict physics standpoint, any rocket that can push a payload into GTO has the exact trajectory and the exact energy required to deliver a nuclear warhead to any specific coordinate on the surface of the Earth. In fact, a standard ballistic missile trajectory is actually simpler. The payload is typically lighter and the guidance is less demanding than a GTO insertion. Japan absolutely has ICBM technology. They just officially call it a space launch vehicle.
And that brings us to this staggering number, 6.5 tons. That is the massive payload capacity of Japan's newest launch vehicle, the H-3 rocket, which just nailed its first successful orbital mission in February 2024. 6.5 tons to geostationary transfer orbit is absolutely massive in the aerospace world. Hold on to that number, because it completely changes the context of what we're looking at next.
Let's put that into perspective. Look at the sheer scale of the H-3's capability compared to top-tier military hardware. JAXA's H-3 lifts 6.5 tons. China's DF-41, which is one of the most advanced top-tier military intercontinental ballistic missiles on Earth, carries about 2.5 tons. And a typical nuclear warhead, that's just 1 to 2 tons. So Japan's civilian rocket isn't just capable, it's vastly over-engineered for a standard nuclear delivery mission.
Now, to be absolutely clear, this isn't some wild conspiracy theory. We are simply putting a civilian space agency and a latent nuclear power side by side and looking at the raw physics. The mechanical overlap is so seamless that literally every intelligence agency on Earth factors this into their strategic calculations. So let's break down exactly what a nation needs to become a nuclear ballistic power.
Building a nuclear ballistic missile basically requires 3 exact components. First, fissile material. Well, Japan has 46 tons of plutonium sitting in storage. Second, warhead design capability. They have world-class supercomputers with the massive computational power required to simulate it. And third, delivery vehicles. We just saw their flight-proven HAJ and H-3 rockets. So they have all 3. The only missing element is the political green light to bolt them together. Let's see how this builds into specific missile technologies.
This specific engineering parallel is so fascinating. The H-3 rocket uses liquid hydrogen and oxygen for its main stage, sure, but it relies on SRB-3 solid rocket boosters. In space applications, these just provide extra thrust. But in a military application, solid fuel technology is everything. Liquid fuel rockets take hours to fuel up, which basically makes them sitting ducks on a launch pad. Solid fuel rockets, on the other hand, can be stored fully fueled and are ready for immediate launch. This indigenous solid fuel technology is the exact foundation of every modern, highly survivable ICBM and submarine-launched ballistic missile in the world today.
Japan also built the smaller Epsilon rocket for science. But because it's fully solid fuel, it can be driven on a road, erected, and launched right from a mobile platform. Functionally, this science experiment serves as a perfect engineering proof of concept for a rapidly deployable, highly survivable nuclear deterrent. Okay, Section 1. Eyes in the sky. The IGS constellation.
Of course, a delivery vehicle is completely useless without a target. Enter the Information Gathering Satellite Program, or IGS, which was actually established right after a North Korean missile flew over Japan in 1998. Just look at these specs. We're talking sub-meter optical resolution, capable of identifying individual vehicles, and synthetic aperture radar that sees straight through clouds and the dead of night. This isn't just weather tracking, folks. This is independent, military-grade strategic intelligence for targeting and battle damage assessment, meaning you aren't waiting around on U.S. data.
And to guide a weapon to those targets, you need extreme precision. Japan is developing the QZSS, a regional satellite navigation system.
Its stated civilian purpose is supplementing GPS to provide centimeter-level positioning over Japan and the Western Pacific. But functionally, centimeter-level positioning is the exact precision guidance required to steer a Tomahawk cruise missile or an indigenously produced guided weapon right through a specific window.
Moving on to Section 2, the anti-satellite dimension.
ASAT operations.
Stepping beyond simply looking down at the Earth, let's talk about orbital combat. Japan has never conducted a kinetic anti-satellite test like China or India. But look at the HTV-X resupply vehicle. It autonomously rendezvous and docks with the International Space Station. Mechanically speaking, the ability to maneuver, approach, and dock with an object moving at thousands of miles per hour is exactly how you hunt down and intercept an enemy satellite to disable it.
Then we have the absolutely legendary Hayabusa and Hayabusa 2 missions, returning samples from distant asteroids. Incredible science, right? But the extreme precision navigation required to pull that off in deep space far, far exceeds the requirements for advanced orbital maneuvering around Earth. The agility needed for that level of science is the exact agility needed for profound proximity operations against adversary space assets.
And here is the ultimate dual-use coincidence: space sustainability. Japan has this noble, highly publicized program to clean up space debris using a magnetic tethering system to capture dead satellites. But functionally, a system designed to capture an unresponsive object in space and violently drag it down into the atmosphere to burn up? Well, that is completely indistinguishable from a military weapon designed to deorbit an adversary's multi-million-dollar communications satellite.
To manage all of this, Japan's 2022 National Security Strategy officially designated space as an operational domain. By integrating deeply with U.S. Space Command, their newly established Space Operations Group uses ground-based telescopes and radars to get real-time tracking of Russian and Chinese orbital movements. They are fully aware of their neighborhood and potential anti-satellite threats.
Let's revisit that staggering anchor number for a second: 46 tons. When you have the rockets, the precision satellites that see through the night, the supercomputers, and 46 tons of fissile material just sitting there in storage, the timeline from quote-unquote peaceful nation to nuclear power shrinks drastically.
In fact, intelligence assessments suggest a sobering reality. By combining these fully developed, civilian-tested engineering milestones, the H3 rocket, the supercomputers, the IGS targeting, and the plutonium, Japan's latent nuclear strike capability could be weaponized and fully operational in a matter of months, not years.
Which brings us to a really crucial geopolitical rule from our source material. Capability matters more than intent. Intent changes overnight. Capability takes decades. There is currently zero evidence that Japan actually intends to build nuclear missiles. But in international geopolitics, what a nation says it will do matters far less to its adversaries than what it can do. And the engineering? It's already finished.
And this creates what we call the latent deterrent. Japan's unique contradictions are exactly what makes its position so incredibly strong. It is famously a pacifist nation that just happens to wield ICBM-grade technology, because regional adversaries like North Korea, China, and Russia must calculate their strategies based on Japan's proven engineering capability rather than just its peaceful intent. Japan's ambiguity becomes a powerful tool. They don't actually need a warhead to benefit from the deterrence of everyone knowing they could build one almost immediately.
So we are left with a fascinating paradox: a civilian space agency providing top-tier military capability. It really begs the question, is Japan's space program truly just civilian? And does this dual-use capability, this latent arsenal hiding in plain sight, make the region safer or more dangerous? Thank you for joining me for this explainer, and keep questioning the engineering behind the exploration.